about simplifying square roots. We've been doing this for quite some time. For example, if I have the square root of 36, well, that equals 6. Okay? That square root symbol is defined to equal the positive root. I know some of you might be thinking, well, can it be 6 or negative 6? And the answer is, well, no, because that symbol, by definition, means what is the positive root of 36. Okay? We've also simplified more complicated things like the square root of 200. If you remember, we look for a factor of 200 that's on my perfect square list. I think 100 is a good choice there. You can rewrite 200 as 100 times 2. Knowing what we know about square roots, I can separate those. Those are equivalent. Square root of 100 is 10 times the square root of 2. So square root of 200 is exactly the same as 10 times the square root of 2. This is a simplified version. But if I put the square root of 200 in my calculator, I would get the same decimal approximation as what I would get if I put 10 times the square root of 2 in your calculator. You can go ahead and try that. So what we're going to do today is we're going to throw some variables into the mix. Okay? Square root of x squared. Now we've talked about this, that when you take the square root of a variable that's squared, you always want to keep in mind that your answer is going to be plus or minus, right? Because that variable could either be a positive or a negative number. So keep that in mind as we go throughout this lesson. I'm not going to keep putting the plus or minus there, but when you are solving an equation involving square roots, you do always have to keep that plus or minus. But for our purposes right now, I'm just going to be dispensing with the plus or minus. I hope you're okay with that. So what would happen if I want to take the square root of x to the 6th? I'm looking for something times itself that equals x to the 6th. Well, if we think about our exponent rules, I know that x to the 3rd times x to the 3rd equals x to the 3 plus 3, or 6. All right, so that means that the square root of x to the 6th must be x to the 3rd. That seems pretty reasonable. How about the square root of x to the 100th times y to the 8th? Well, same thing. Let's look and think. What times itself would equal x to the 100? Oh, well, x to the 50, right? X to the 50th times x to the 50th, that equals x to the 50 plus 50, or 100. What times itself equals y to the 8th? That's going to be y to the 4th for the same reason. Y to the 4th, y to the 4th, y to the 8th. Alrighty? Now, another way to think about that is to think about another way to write these square roots. If you recall, the square root of x can be written as x to the 1/2. There's a little invisible 1 exponent. There's a little invisible 2 root. So I can rewrite this radical as x to the 1/2. Does that make sense? All right, so let's revisit these with that in mind. X to the 6th, if I have a little index, or sorry, a little root there of 2, I could rewrite that as x to the 6/2. Oh, well, x to the 6th divided by 2 is x to the 3rd. So that's another way you can think about this. Same thing here. I could rewrite this as x to the 100th times y to the 8th, all raised to the 1/2. We know when we're raising a power to a power, we multiply. So that's 100 times 1/2, which is 50. Y to the 8 times 1/2, which is 4. So you can think about it that way. And again, we're assuming for our purposes that all of the variables that we're using are positive or greater than 0. Okay? So if we weren't assuming that, we'd put a little plus or minus in front of everything. But for our purposes, we're going to assume that our variables are greater than 0. Okay? So What happens if I'm faced with something like this? X to the 7th. What times itself equals x to the 7th? Well, some of you clever people out there might be thinking, well, wouldn't that be x to the 3.5? Yeah, because x to the 3.5 times x to the 3.5 equals x to the 7th, right? Or, if you rewrote it, x to the 7 halves, that would equal x to the 3.5. And you would be correct. But if I want to simplify my square roots and leave my answers as in simplest radical form, this would not be considered simplest radical form. It would be correct. This is perfectly correct. But it would not be considered simplest radical form. So let's kind of unpack that a little bit and see what I'm talking about. If I'm looking at the square root of x to the 7th, and I'm doing it this way, really I'm saying x to the 3.5, I'm going to write it like that, right? That's really x to the 3rd times x to the 1/2. Are you with me here? Right? Just going backwards with our power of exponents. Oh, well, isn't that x to the 3rd times the square root of x? Yes, it is. This would be considered a simplest radical form of the square root of x to the 7th. Okay? Now, this is one way to do it, where you rewrite your radical with a fractional exponent, and then you kind of separate those out and write it in radical form. But there might be an easier way to think about this. Okay? So let me show you a couple other strategies, and you can decide which strategy works for you. All right, so if I'm wanting to write this in simplest radical form, another strategy is to think kind of like what we did with the square root of 200. Think to yourself, what would be a perfect square? What's a factor of x to the 7th that is a perfect square? Oh, well, x to the 6th is a perfect square, right? Because x to the 3rd times itself is x to the 6th. So I can rewrite x to the 7th as x to the 6th times x to the 1th. All right, well, the x to the 6th is a perfect square, so I can bring that out as x to the 3rd, leaving x inside the square root. So that's a second way to do it, okay? So our first way was rewriting the radical or the square root with a rational exponent, a fractional exponent, and then kind of separating them. This other method is to rewrite your x to the 7th as in its factors, where one factor is a perfect square, and then you take out the perfect square and leave behind the leftovers. And the third method, which most people find the easiest, is to kind of just think through this process and say, okay, 2 goes into 7 how many times? 3 times, with a remainder of 1. Okay? So you're dividing 2 into 7 3 times with a remainder of 1. All right? So those are kind of 3 ways to do that same problem. So let's just do a couple of these. And again, our instructions would be leave in simplest radical form. If we're asked to do that, then this is how we're going to do it. All right, let's throw in a number there too. Let's say we have 50 times a to the 12th, b to the 21st, and c to the, I don't know, 15th. How's that? And again, we're assuming A, B, and C are all positive for our purposes. Otherwise, we'd have to remember our little plus or minus business. Okay, so I'm going to first deal with that 50. Square root of 50, well, 50 is not a perfect square, but a 25 is. So I'm going to rewrite 50 as square root of 25 times 2. And the square root of 25 is 5. So far I have a 5 outside of my radical, and I have a 2 left behind inside my radical. So far, so good. All right, let's look at a to the 12th. Well, a to the 12th, that's a perfect square, right? If you think about this little 2, a to the 12 halves is a to the 6th. And sure enough, a to the 6th times itself equals a to the 12th. All right, so we're good with that. Let's go to the b to the 21th. Well, if I'm rewriting this, b to the 21 divided by 2, that's not going to come out nicely. But let's see, b goes into 21 how many times? 10 times. Is that correct? So I think I can take out b to the 10th. And I have 1b left over. Okay, c to the 15 halves. Well, again, 2 doesn't go into 15, it goes into 14 7 times. I'm running out of room here, I see. I'm going to need a little more room. So I can take out c to the 7th, and I have 1 left over. Let's just make sure this works. So I have 5. If I put that back in, 5 squared is 25 times 2. That works, 20. a to the 6th times a to the 6th is a to the 12th. And that's what I had. b to the 10th times itself. b to the 10th is b to the 20th plus 1. That would give me b to the 21th. c to the 7th times itself would be c to the 14 plus 1 left over. Okay, that gives us our original. So I just simplified this original square root, and I left it in simplest form, simplest radical form. Alrighty, how are we feeling about that? Are we feeling okay?